Q5203. Which statement is true regarding the opposing forces acting on an airplane in steady-state level flight? A. These forces are equal. B. Thrust is greater than drag and weight and lift are equal. C. Thrust is greater than drag and lift is greater than weight. The correct answer is A. In steady-state level flight, the opposing forces acting on an airplane are in balance, which means that they are equal. The four main forces acting on an airplane in steady-state level flight are thrust, drag, lift, and weight. Thrust is the forward force produced by the engines or propulsion system, which counteracts drag, the resistance encountered by the airplane as it moves through the air. Lift is the upward force generated by the wings, which counteracts weight, the force exerted by gravity pulling the airplane downward. For the airplane to maintain steady-state level flight, the four forces must be in equilibrium. This means that lift must be equal to weight, and thrust must be equal to drag. If any of these forces were greater than the others, the airplane would not be able to maintain its level flight. 5223. To generate the same amount of lift as altitude is increased, an airplane must be flown at A. The same true airspeed regardless of angle of attack. B. A lower true airspeed and a greater angle of attack. C. A higher true airspeed for any given angle of attack. The correct answer is C. To generate the same amount of lift as altitude is increased, an airplane must be flown at a higher true airspeed for any given angle of attack. As an airplane climbs to higher altitudes, the air density decreases. Since lift is directly proportional to air density, the reduced air density at higher altitudes requires adjustments to maintain the same amount of lift. To compensate for the reduced air density, the airplane needs to fly at a higher true airspeed. By increasing the true airspeed, the dynamic pressure acting on the wings is increased, helping to maintain the same lift force. While a higher angle of attack can contribute to generating more lift, it has limits. Increasing the angle of attack beyond a certain point can lead to flow separation and loss of lift, which is undesirable. Therefore, to generate the same amount of lift as altitude is increased, the airplane must be flown at a higher true airspeed for any given angle of attack. 5229. What changes in airplane longitudinal control must be made to maintain altitude while the airspeed is being decreased? A. Increase the angle of attack to produce more lift than drag. B. Increase the angle of attack to compensate for the decreasing lift. C. Decrease the angle of attack to compensate for the increasing drag. The correct answer is B. To maintain altitude while the airspeed is being decreased, the airplane must increase the angle of attack to compensate for the decreasing lift. As airspeed decreases, the dynamic pressure acting on the wings decreases. Lift is directly proportional to dynamic pressure, so as the airspeed decreases, the lift generated by the wings also decreases. To counteract this decrease in lift, the angle of attack must be increased. Increasing the angle of attack allows the wings to generate more lift at the lower airspeed, compensating for the decreasing lift due to the reduced dynamic pressure. By increasing the angle of attack, the wings can maintain sufficient lift to balance the airplane's weight and maintain altitude. Therefore, the correct answer is to increase the angle of attack to compensate for the decreasing lift. 5161. In theory, if the airspeed of an airplane is doubled while in level flight, parasite drag will become A. Twice as great. B. Half as great. C. 4 times greater. The correct answer is C. At high speeds, parasite drag has a greater impact, while induced drag has a greater impact at low speeds. For instance, the parasite drag increases 4 times if an airplane accelerates from a steady flight state of 100 knots to 200 knots. 5161-1. In theory, if the airspeed of an aircraft in level flight is cut in half, parasite drag will become A. 1/3 as much. B. 1/2 as much. C. 1/4 as much. The correct answer is C. In theory, if the airspeed of an aircraft in level flight is cut in half, the parasite drag will become 1/4 as much. As mentioned before, parasite drag is the component of drag that is primarily influenced by factors such as the shape of the aircraft, surface roughness, and non-lift producing parts. It is directly proportional to the square of the airspeed. When the airspeed is halved, the dynamic pressure acting on the aircraft surfaces is reduced by a factor of 4 since it is proportional to the square of the airspeed. As a result, the parasite drag will also decrease by a factor of 4. Therefore, the correct answer is that the parasite drag will become 1/4 as much if the airspeed of an aircraft in level flight is cut in half.